Next, result. If the input x of t and its output y of t are defined by y of t is equal to integral minus infinite to plus infinite h of u x of t minus u du, then the system is linear time invariant system. Right? We'll see the proof. Given y of t is equal to integral minus infinite to plus infinite h of u x of t minus u du. That is equation number 1. To prove the system is linear, to prove if the input x of t is equal to a x1 of t plus b x2 of t, where a and b are constant, then the output will be y of t is equal to a y1 of t plus b y2 of t. So to prove linear, we can prove like this, right? So let x of t is equal to a x1 of t plus b x2 of t. This is equation number 2. 1 implies y of t is equal to minus integral to plus integral minus infinite to plus infinite h of u x of t minus u du is equal to minus infinite to plus infinite h of u. So replacing x of t minus u, right, a into x1 of t minus u plus b x2 of t minus u du by using 2. So this is equal to integral minus infinite to plus infinite a h of u x1 t minus u du. We are splitting the integral into 2, and the integral minus infinite to plus infinite b h of u x of 2 x2 of t minus u du. So taking a and b constant, take it outside from the integral, a into integral minus infinite to plus infinite h of u x1 of t minus u du plus b into integral minus infinite to plus infinite h of u x2 of t minus u du. So a into this integral is nothing but y1 of t. Second integral plus b into that is nothing but y2 of t using 1. Right? Hence the given system is a linear system. To prove the system is time invariant, first we proved this is a linear system, then we need to prove time invariant, because we need to prove system is linear time invariant. First we proved the system is linear, now we are going to prove time invariant. So put t is equal to t plus h. That is, replace t by t plus h in the input x of t. Y of t is equal to integral minus infinite to plus infinite h of u x of t plus h minus u du. That is my integral minus infinite to plus infinite h of u x of t plus h minus u du. That is equal to y of t plus h. Instead of t, you are having t plus h. That's all. So we are replacing. So y of t plus h. Hence, y of t is equal to y of t plus h. Because time invariant means with respect to time, it will not change. That means time invariant. So y of t, which is equal to y of t plus h. Hence, the system is time invariant. Therefore, the system is a linear time invariant system. Result 2. If the input to a time invariant stable linear system is a WSS process, then the output will also be a WSS process. To show that if x of t is a WSS process, then the output y of t is a WSS process. Right? We know that input and output relation is given by y of t is equal to integral minus infinite to plus infinite h of u x of t minus u du. That is equation number 1. Given x of t is a WSS process, this implies first condition, mean is a constant, expected value of x of t is a constant, say mu of x, mu x. Then Rx of tau is a function of tau. That is equation number 2. To prove y of t is a WSS process, that is to prove that mean expected value of y of t is constant, Ryy of tau is a function of tau. From 1, expected value of y of t, which is equal to expected value of integral minus infinite to plus infinite h of u x of t minus u du. So without loss in generality, we are taking a expectation inside the integral. So we are taking h of u into expected value of x of t minus u du. Right? That is equal to because expected value is only for the time, right? Expected value of y of t we are taking. That is why h of u is constant with respect to the expectation. So we are taking only for the expectation for x of t minus u. Integral minus infinite to plus infinite h of u, expected value of x, expected value of x of t means expected value of x of t1, x of t2, x of t3, x of t minus 4, x of t minus 5, all are the mean only, right? So x of expected value of x of t minus u is nothing but mu x, right? Mu x is a constant, so taking outside from the integral, mu x integral minus infinite to plus infinite h of u du, that is the finite one, right? So given system is stable, bounded inputs gives bounded outputs, right? That is the rule. So bounded input, if it is x of t is bounded, then y of t also bounded, so stable. Therefore e of y of t is a constant, equation number 3. Now we'll see the autocorrelation RYY of tau, which is equal to expected value of y of t plus tau, which is equal to expected value of integral minus infinite to plus infinite h of u1 x of t minus u1 du1, then integral minus infinite to plus infinite h of u2 x of t plus tau minus u2 du2, right? We are using 1. So it is equal to expected value of integral minus infinite to plus infinite, integral minus infinite to plus infinite h of u1 h of u2 x of t minus u1 x of t plus tau minus u2 du1 du2. We are grouping all those things, right? Now it is equal to, we are taking the expectation to the x values, right? Because x is having t, right? So minus infinite to plus infinite, integral minus infinite to plus infinite h of u1 h of u2, expected value of x of t minus u1 x of t plus tau minus u2 du1 du2, which is equal to expected value of x of t minus u1 x of t plus tau minus u2 is nothing but x of t, right? Expected value of x of t into x of t plus tau, right? So so whatever the t value, so you are considering only the time t, right? X of t plus tau, expected value of x of t plus tau. Here you are having x of t minus u1, whatever it is, x of t plus tau, time is increased, right? Minus u2, whatever it is. So that is nothing but autocorrelation rx of t minus u1 minus u2, right? So that is time difference, right? So rx of tau, how we are putting tau? So the time is t x of t plus tau. The difference is t plus tau minus t, you will get tau. Here you are having t plus tau minus u2, right? So they see same difference, minus t u1, right? X of t plus tau minus t, you will get tau minus u1 minus u2. So du1 du2 rx of tau minus u1 minus u2, that is expected value of x of t minus u1 x of t plus tau minus u2. You can replace minus u1 by plus u1 also, correct only. So the same thing you will get, no problem. So we know that from 2 rx of tau is a function of tau. Therefore rx of tau minus u1 minus u2 also a function of tau. Therefore ryy of tau is a function of tau 4. From 3 and 4, y of t is a WSS process. Thanks. We'll see you in the next video.